Hello everyone, today I will start a new series of educational videos focusing on general machine learning and data analysis. The machine learning class taught by Professor Ng in Stanford University is perhaps the most popular introductory online class. So I will start from writing the programming assignment of this class. Today's exercise is about linear regression. The dataset comes from the UCR repository. It is the housing data. I have downloaded it to my local drive. The first part of the code is just a preparation. First, loading several Python modules which will be used in this program. Then change the directory to where the housing data saved. Since the housing data is in text format, so we use NumPy load text to load the data into NumPy array. So next, we can plot the data for the visual observation. Before doing a linear regression, we have a couple things to do. First, we have to add a column of 1s to the dataset to act as the θ0 intercept term. Then, we random shuffle the data and split them into the training and testing set. Our goal is to find the choice of theta so that the predicted housing price is as close as possible to the actual price. The cost function in this problem will measure how much error is in the predicting price for a particular choice of theta. Let's write a cost function in matrix vectorial notation. Matrix X is m by n dimension. Each row represents a transpose of feature vector. The feature vector is n dimension, and the theta is n-dimension vector. The price y is m-dimension vector. Loss function is defined as half of a sum of error square. Its gradient is the derivative with respect of theta. Here is a gradient in matrix expression. So we implement the cost function and its gradient in the matrix vectorial form and initialize the theta with a random number. The code then will call SciPy minimization function to find the best choice of theta. To view the fitting errors during minimization process, we create a callback function to return the loss function during each iteration. After minimization complete, print the training and the testing errors. Also plot the predict and the actual prices for the samples in the testing set. Okay, that's all for today. Thank you for watching. See you next episode.